Moving on, we are to do combination of operations, and we have 4 questions altogether. Let's look at the first example. You have this product inside the parentheses to the power 2. So if you are to look at the components we have, I believe you should see 3. You have minus 2, a, and b cubed. So we are to distribute the power 2 to each of the component to remove the parentheses. So minus 2 in parentheses to the power 2 and separated by the multiplication, and you have a, so a to the power 2 and b cubed to the power 2. And let's simplify, starting from the left. Minus 2, everything in parentheses squared should give you 4. A squared, straightforward. And if you are to look at b to the power 3 in parentheses and then to the power of 2, this is indeed a power of another. We are to multiply the power to remove the parentheses. So 3 times 2 and b to this power. Let's simplify that. So 3 times 2 should give you 6. So b to the power of 6. Moving on, the question on the right, if you notice that we have 2 multiplication sign, 1 and 2, and we are to perform 2 operations. So we are to start from the left to the right using the Batmath rule. So let's simplify 4e times minus 7f first, and then using this answer to multiply by our 2g. So let me rewrite it here, 4e times minus 7f. So we are to break this apart. So first you have the numbers 4 and minus 7. They are being multiplied. So 4 times minus 7. I believe that should give you minus 28. And then you have the variable e, and no e in your second term, and you have the f, and you should combine the results you get. You have minus 28 e and f, and we are to use that to multiply by 2g. And again, we are to break the components apart. First, let's look at the numbers. You have minus 28 and 2. So I believe that should give you minus 56. And we have e. I believe e is on its own. F is on its own. And g, no g in the first term, so g is on its own. And I believe that is everything we have. And we are to combine the answer to get our final result. Minus 56 e f and g. That should be your final answer. Moving on, if you are to closely look at this question, I believe you see that at the denominator, you see there is a product of a power. So let's simplify the product of a power first, and then we are to perform the division. So let's do it on the side. So you have 2p squared q, everything to the power of 3. We have 3 components here, 2p squared and q. So we are to distribute to each the components we have. So 2 cubed times p squared, everything cubed, and q cubed. And let's simplify this expression. 2 cubed should give you 8. And remember, p squared and to another power, you are to multiply the powers. So I believe 2 times 3, p to the power of 2 times 3, and q cubed. Let's simplify the exponent for p, so I believe you should get 6. And now we are to rewrite our denominator in terms of the ones we simplified. So you have h p to the power of 6 q cubed. On the numerator, just put whatever was there, remain unchanged. And the next step, you are to separate the components, numbers to numbers. So you have 24 over 8, and each component is joined by this multiplication sign, and you have p to the power of 6 over p to the power of 6. And you have q to the power of 4 over q to the power of 3. Let's simplify them on the right. So numbers are easy. 24 divided by 8 should give you 3. P to the power of 6 divided by p to the power of 6. First, you should check the base. Base is the same, both p. And then we are to perform division. So division, you subtract the power. P to the power of 6 minus 6. I believe that should give you p to the power of 0. Remember that any non-zero base to the power of 0 will always give you 1. And we already assume that this is a non-zero p. So you get 1. And the last, you have q. I believe q, they have the same base and performing division. So you are to subtract the power. Q to the power of 4 minus 3. That should give you q. So attach the q. I believe you should get your final answer as 3q.